Question 2. An experiment is carried out to determine the relative molecular mass of volatile hydrocarbon X as a liquid at room temperature. Known mass of X was vaporized at a known temperature and pressure, and the volume of gas produced was measured in a gas syringe. Data from the experiment is shown in Table 1. Calculate relative molecular mass of X. So we want to find out the MR. Obviously going to use the ideal gas equation, PV equals nRT. We need to rearrange it to find out N, the number of moles. Well, the number of moles is going to be PV divided by RT. Don't just write N is equal to PV over RT. Show this and then the rearrangement. So N is equal to pressure in pascals. So 102 pascals, 2000 PA. Mass, well, obviously that's going to be 0.194 grams. Temperature is already in Kelvin, so that's fine. Volume, well, volume measured in meters cubed and PV equals nRT. So what do we have to do? We have to do 72 divided by a million. So it's going to be pressure in pascals 102,000 times by volume 72 times by 10 to the power minus 6 because we want it meters cubed divided by R, which is 8.31, times by the temperature is already in Kelvin, 373. That gives me the number of moles is equal to 2.369 times by 10 to the power minus 3. Now I know moles is equal to mass of MR. What are we trying to find? We are trying to find the molecular mass. We're trying to find the MR. So therefore the MR is going to be the mass divided by moles. We just rearrange it. Times by MR divided by moles. So MR is going to be the mass in grams, which is this. So it's going to be MR equals 0.194 divided by the moles, 2.369 times by 10 to the power minus 3. And that will give me that will give me 81.89. Label that as the MR. Therefore MR is 82 to 2 significant figures. Because it does say give your answer to appropriate numbers of different figures. That's the end of question 2.1. 2.2. An analysis of different hydrocarbon Y shows that contains this much of carbon. Calculate empirical formula and then use the empirical formula, and the relative molecular mass of Y MR is 86.0 to calculate the molecular formula. So a hydrocarbon, well, a hydrocarbon only contains hydrocarbon is a compound made of atoms of hydrogen and carbon only. So what we're going to do, we're going to find out the moles. So moles of carbon, that's going to be 83.7, that's mass, divided by MR, which is 12, to, well, what's the mass of hydrogen? Well, we know total percentage must be 100, so to find out the mass of hydrogen is going to be 100 minus 83.7, which give me 16.3%. So therefore the mass is going to be 16.3 and the MR of hydrogen is 1. So what do we get? 6.975 to 16.3 divided by 1 is 16.3. Now we need to divide by the smallest small ratio, which is going to be 6.975, because 16.1 is clearly bigger than 6.975. And we'll get 1 to 2.3 4, and therefore if we times both sides by 3, we'll get 3 to 7. Well, we get 3 to 7.02, but therefore we can round it to 7. So the empirical formula, well, this is for the carbon, this side, and this is for the hydrogen, which is 7. It's going to be C3H7. That's the empirical formula. Now the molecular formula, well, we know the MR is 86.0. So what we just need to do is, let's see if we double it, what will happen? Well, we'll get C6H14. What's the MR of that? 12 times by 6 plus 14, that is 86. That is equal to 86.0. Therefore, C6H14 is the molecular formula. That's how you do it. This one, it was pretty simple. We just need to times it by 2. But in some cases, it could be times it by 3, maybe 4, 5, and that's why you need to read the question properly. So you're given the MR, so therefore you can find out the molecular formula. And that is the end of question 2.